Welcome back. We got a data set we're going to use today. Let me show it to you here at the top of the screen. It's a data set from Business Statistics 2nd edition, Pearson book. The data set is called Housing Prices Zillow. And we're going to use that to illustrate how to use multiple regression for predictive modeling. I've done a couple of things with the data set before we started. One is I was looking at the fireplaces as a continuous variable you can see here, and also create a categorical version of that with a yes, no fireplaces, or yes, one or more fireplaces. And then I created a validation column. For predictive modeling, really what we are concerned about is how well can we predict a new observation. And so to assess that, what we do is take our data. In this case, we have a little bit over 1,000 observations, 1,000 rows, and we divide it into, or we partition it into a training and a validation set. And so I partitioned it into 70% training, 30% validation. So we'll develop the model with that 70% of the observations, so roughly 700 rows, to train it. And then to see how well it works with new data, we'll assess it against a validation, which is at 30%. Okay, let's get started. We're going to develop a predictive model for price, and we're just going to use 3 variables to show the process here. Before we get into that, though, it's good to remind ourselves that really in every type of analysis we're doing, we start by examining, exploring, understanding the data. And so we would use some techniques such as analyzing distribution for looking at the data one at a time, fit y by x, look at 2 at a time, and then the multivariate methods to look at comparing the continuous variables, each with all the others. To go into the multiple regression predictive modeling, I go to Analyze and Fit Model. I'm going to put price in the Y and these 3 variables in the model effects. And that would allow us to do a multiple regression model. I take this validation column and put it in the validation row, and that will allow us to assess how well our model is working. So I click Run. We can sort of work top to bottom and see the R squared adjusted about 59%. Our overall ANOVA table saying that the null is that all the parameters, those coefficients, are equal to 0 versus at least one's not, and it says, all right, we've got at least something working in the model. Allows us to look at all the parameters and their coefficients and their p-values. We can see they're all significant. But then this is what allows us to assess how well the model's working. And you can see that the RASC, root absolute squared error, is really the primary metric that we'll use in multiple regression to see how well it fit new data. And we can see that for the validation set, the value of about 44,000, in this case that'd be $44,000, predicting that housing price. This is a very similar to measure to root mean square error, so if you understand how to think about that, you could think about this in a similar way. Now, something else we could do that would help us understand the variability, so we can assess if this is a predictive model that's going to be useful, is we go up here to the triangle and save columns and save the prediction formula, save columns, save the mean confidence limit formula, and then save the individual confidence limit formula. And then to give us something to compare it to, let's just create another row in which we look at how it would work against some new sample. So say we had 2,000 square foot living area, 4 bedrooms, 4 baths. Then we could see on average this prediction would be that's about a $229,000 home, and the 95% confidence interval around that average is between about 212,000, call it, and 246,000. So we can think about that average width, the confidence interval, whether that's useful. And then we have these two values, which give us a 95% prediction interval. And you can think about that if that next house coming on the market is 2,000 square feet, 4 bedroom, 4 bath, 95% prediction interval is between 127,000 and 330,000. And so we'd have to think about whether that widespread there is going to make this a useful predictive model for us. That's it. Thanks. See you next time.